6, we want to clarify this is right or wrong. This is everything depend on the x and y values. In this sum, there is no clear instruction about x and the y aspect of x and y, whether x is constant or y is x is positive or y is positive or both negative. This inequality depend on the x and y values. Yes, this is true for some. For example, assume that x equal 10 and this is 2, right? And this is 10 plus 10 cube plus 2 cube, right? When you expand this one, yes, 10 square plus this is the 3x cubic expansion, 10 3 times 10 square times 2 plus 3 times 10 2 square plus 2 3. Now yes, definitely when you look at this one, this is greater than this one. Let's see the situation of different sum. So if x and y is positive, yes, this is true. But what will happen x and y is negative? Okay. Before that, we'll think about, okay, x and y equals 0. 0 plus 0 cube greater than 0 plus 0 cube. This is 0 greater than 0. This is bit contradict. 0 equal to 0, not 0 greater than 0. And assume this is 10 minus 2. It means 10 plus minus 2. 10 plus minus 2 cube is great, whether it is greater than 10 cube plus minus 2 cube. Let's see whether this is true or false. Now this is 10 cube plus 3 times 10 square minus 2 plus 3 times 10 minus 2 square plus minus 2 cube greater than 10 cube minus 8. Let's see whether this is going to be right. Now this is 10 cube is 1000. This is 10 square 100 times 3 300 double 600 but minus, and this is going to be positive 4. 4 times 3 12 120 and minus 8, right? This is 1000 and minus 8. So this is 902. What is this answer? 1000 1120 1120 minus 608. 412. Is 412 greater than 902? No. So it is totally depend on the value. If you give this one x greater than 0 and y greater than 0, it means it's not equal to 7, not equal to 0. Then this is a valid equation. The problem is in this question, the student is trying to prove this one and yes, identify the error made in this proof. So he said this one 3x square y 3xy square greater than 0. It is whether it is greater than 0 or less than 0 depend on the x and y's. So this is one assumption he made wrong. And so good example is actually we discussed this one when x equals 0. When x equals 0, okay. Wrong assumption by the student as 3x square y plus 3xy square greater than 0. And part D, what is it? Prove the counter example. Yes, counter example is when x equals 0 and y equals 0, 0 plus 0 cube is greater than 0. This is a easy one. So this is contradict. Or even you can get x equal 10 and y equal minus 2, and you can show that this is wrong. But yes, this is enough. Question number 7. When I look at this one, so prove that the real values of x plus 6x square greater than 2x plus 11. Now I need to get a start. So first of all, I will see what is going on here. When I expand this one, x square plus 12x plus 36 greater than equal to 2x plus 11. So I'll bring this one to left. X square plus 12x minus 2x, 30x minus 11 greater than or equal to 0. This x square plus 10x plus 25 greater than, okay, this is x plus 5 square greater than or equal to 0. Oh, this is a good sign. So I'm going to start. We know that x plus 5 square, this is my answer, greater than or equal to 0. If you add any values, the add or minus, the to both side, the inequality stay the same, right? It doesn't matter minus or plus. If you do same thing, we didn't multiply by minus or divide, so this is just addition, stay the same. Now I'll expand and see x square plus 10x plus, I know what is going on now here, but I don't show. This is to examiner, and this is going to be 25 and 2x plus 11 greater than or equal to 2x plus 11. So now this is going to be x square 12x plus 36 greater than or equal to 2x plus 11. It means x plus 6x square greater than or equal to 2x plus 11. Another approach. Can you see that x plus 6x square equal the same thing, x plus 5 square plus 2x plus 11. Now this is a inequality, equality, but we 100% sure that this is positive. X plus 5 square greater than 0, greater than or equal to 100%. Hence x plus 6x square minus x, okay, hence x plus 6x square greater than or equal to 2x plus 11. I simply will take this out because I know it is positive. When I take positive things out, the left side become bigger. Question number 8. We want to show that a greater than 0. Yeah? So a plus 1 or a greater than or equal to 0. So just simplify and see what is going on. I multiply by a because a greater is positive. I can do so. Then this is going to be 1 and this is going to be 2a. So a square minus 2a plus 1 greater than 0. It means a minus 1 square. This is greater than 0. Now we have to work like that, right? So a minus 1 greater than or equal to 0. Then a square minus 2a plus 1 greater than 0. Then divide by both sides a, because a greater than 0 inequality stay the same. It means a minus, this is going to be a square over a 2a over a plus 1 over a greater than equal to 0. A minus 2 plus 1 over a greater than equal to 0. It means a plus 1 over a greater than equal to 2. We start with something is very true. So we can start. It is reasonable to start a place like this because we know that a minus 1 square has to be greater than or equal to 0. Nobody can say it is false. Okay, this is a good axiom to start. Question number 9. Um, P plus Q greater than or equal to 4PQ. I'm going to see what is going on here. Um, P plus Q square equal 4PQ. I square this one. P square plus 2PQ plus Q square greater than 4PQ. I'll bring to this one. P square minus 2PQ plus Q square plus 2PQ minus 4PQ plus Q square greater than or equal to 0. I bring to left side. So this is P square minus 2PQ plus Q square greater than equal to 0. This is P minus Q square greater than 0. I found a place to start now. Right now for this one, first of all, yeah, any positive numbers P and Q. So P greater than 0 and Q greater than 0. And we know that it doesn't matter P minus Q square greater than or equal to 0. Then P square, this is the proof. P square minus 2PQ plus Q square greater than 0. Then I am going to add to 4PQ to both sides. Add 4PQ to both sides. I want to add 4PQ to both sides. And you see when I add 4PQ, this is cancelled out and it's going to be here. So likewise, both sides, because and P greater than 0. So argument we want to get P greater than 0, Q greater than 0, hence PQ greater than 0, hence 4PQ greater than 0. Hence I can add the 2PQ plus Q square plus 4PQ to both sides. keeping the inequality same. So I have to show these things to protect the inequality, protect the sign of this inequality as it is. So now this is going to be p square plus 2pq plus q square greater than equal to 4pq. So this is p plus q square greater than 4pq. Then when you take the square root, this is going to be 4pq. Part B, p plus q greater than or equal to 4pq. P plus q greater than or equal to 4 square root 4pq. So now we want to show that if p and q both negative, this doesn't hold. So let's consider, we'll take a value. Let's take p equal minus 10 and q equal minus 10 or minus 20. Then let's substitute minus 10 minus 20 greater than 4 times minus 10 minus 20. So this is going to be 20, 200, 800, square root 800, which is this is 30. It means 400 mean 400 times 2. So this is 20 square root 2 minus 30 is greater than 20 square root 2. So this is impossible. Hence, our assumptions are wrong. So we are disproving this by giving a counter example. So this is a counter example. Question number 10. X square plus y square. Now x and y is negative. Right. If you look at negative number, we discussed earlier as well. The question number 9, we know that this is not going to work. If we put minus 1 and minus 2, you will see that. But his student didn't see this one. So student realize that 2xy is greater than 0 as negative or negative times negative is positive. But he did not realize negative plus negative is negative as x plus y is negative. He only look at minus times minus positive. Yeah, it is fine, but which is true as well. But when you add negative and negative, it doesn't become positive. He did not realize negative plus negative is negative as x plus y is negative. The count example. What is the count example? Let x equal minus 1 and y equal minus 2. So minus 1 plus minus 2 greater than equal to minus 1 square plus minus 2 square. So this is minus 3 greater than equal to square root 5, which is positive number. So this is impossible. Part C, we know that x greater than 0 and y greater than 0, x plus y greater than 0, x plus y square greater than or equal to 0. Actually, you don't need this knowledge. You can, it doesn't matter whatever x plus y greater than or equal to x plus y square greater than or equal to 0. So we'll expand x plus y square. This is going to be x square plus 2x plus y square, 2xy plus y square. Now we can start from here. X plus y square equal to x square plus 2xy plus y square. So if this is positive, then when I take positive out, this will become negative. Greater than left side is greater than right side. If it is negative, this will be greater than right side will be greater than left side. Now, since x greater than 0, y greater than 0, xy greater than 0, and 2xy greater than 0. Hence, x plus y square greater than or equal to x square plus y square, because I can take this one out and the 100% I know this is greater than 0 because this is positive. Now I can simply square root it. Square root x square plus y square. We will be able to square because x plus y is greater than 0, as x plus y greater than 0.